All right, so we're going to move into Unit 4, um, which is going to deal with chemical properties of soil and water. Um, so both will be a little bit of a review. Remember, we talked a lot about water in biology, whether you were in honors bio or agrobiology. So you're going to be asked later this week to go back and kind of review the water cycle and the phase changes water goes through within the water cycle. I'm not going to produce another video on that right now because I do feel like we covered that fairly well prior. But we do need to talk about and remind ourselves of some certain vocab terms as far as water is concerned and how it behaves in soil and how it plays a role um, into plants. So why is water important? Well, water is important if you think back because water is what really allows the process of photosynthesis to reoccur and reoccur and reoccur. Of course, by replenishing those electrons that magnesium loses when it's energized by a photon, more specifically, and that's where we kind of focused on in ag bio or honors biology, whichever you were in. So water is important for that aspect. Water is also going to be considered as a nutrient, and all of the other minerals and nutrients that plants need is going to dissolve in water and can be carried by water in plants. The think back we talked about water is a universal solvent, meaning that most things can dissolve completely in water. So what are the water requirements for plants? Plants use several hundred pounds of water for each pound of dry matter produced. Okay, so say sugar, okay, say glucose. Um, you can look and see there, but you do the math about how much water is needed and how much water is used. Um, and that's just plants. And then so we look at the water supply in the natural world for plants and animals and humans alike, and we really start doing some numbers, and a lot of water gets used on a daily basis. So how does water enter the soil? So it goes through pores in the soil. Sandy soils have the largest pores, but are often filled with other materials. Medium texture soils, we call them loamy, have good water entry properties. Clays pores well shut when they get wet. So the type of soil is going to depend on how much water can be held there, and also plays a role into how much water is available for plants to grow. Um, so again, precipitation water in some shape, form, or fashion lands on top of the ground. It can seep through these pores, and it can be held there, or it could not seep through if it's more clay, or it could leach on through down below the water table. That we see that happening as well. So what water does once it enters the horizons or the first couple of horizons there of the soil profile is going to depend on how much plants or how many plants can grow there and thrive. All right, so remind yourself of what adhesion is, and this is the attraction of two different molecules. So this is water's ability to stick to other surfaces or other substances. Okay, so water is going to stick to soil. Water loves to stick to other surfaces because water is polar. So remember that it's slightly positively charged at one pole, which makes it slightly negatively charged at another pole, which gives it an overall polar charge, which is going to give it the ability to not only like to attach to itself, but also stick and attach to other surfaces. So water is going to stick to soil particles, and how much sticks to it is going to depend on how much water is in the soil. And so cohesion is the attraction of two similar molecules, and this is water water loves itself. It loves to stick to itself. So why is it important, this adhesion and cohesion? Water molecules are strongly attracted to soil minerals and organic materials due to adhesion. Water molecules are also strongly attracted to each other due to cohesion. Soil holds a thin layer of water. That layer holds a thin layer of water, etc., 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 etc. The further away from the soil particle you get, the looser the water is held. And this is the water that's going to be available for plants to uptake. So water that is closely connected to soil particles is going to be hard for plants to uptake in their root system. But if the water on the soil and the water on that water and the water on that water is kind of in these pore spaces, then the root systems of plants are going to be able to take up this water a lot more easily, or a lot easier, I guess is what I should say, than the water that is closely attached to soil particles. So water then tends to move from wetter places to drier places. Roots remove water, and then water is drawn from the surrounding areas. In dry conditions, water moves slowly and only fractions of an inch. Thus, roots must be well distributed. This is where we see, larger root systems that span out over larger areas to have access to more water sources. All right. So, how is soil water classified? Hygroscopic water is held so strongly by soil particles that it is not available to the plants. This is what we were talking about. That first layer of water around soil particles is going to be very hard for plants to pull away. Capillary water is held by cohesive forces greater than gravity, so it is available to plants. So this is the layers of water that are going to be on top of, so to speak, the layer of water around soil particles. So this is going to be that cohesion aspect, water liking to stick to itself. So if you were to draw 4 layers of water around an individual soil particle, layers 2, 3, and 4 would be a lot easier for plant root systems to take up and use than layer 1 right next to the soil particles. So this is capillary water. Gravitational water is water which cannot be held against gravity. As water is pulled down through the soil, nutrients are leached out of the soil. Nitrogen is the big one here. So we all understand what gravity is. It's constantly pushing things down. They are pulling things down. Water is no different. So as water moves through the soil, there's gravitational water that is not adhesive to anything or cohesive to other water. It is going to pull nutrients out of the soil as it moves downward. Okay, and this is known as leaching. So, what is field capacity? So, field capacity is when the soil contains a maximum amount of available water, the greatest amount of water it can hold against gravity. Okay, so this is important to know because different types of soil have a different type of field capacity. There, it can be too much. And this is when we see standing water. That we call it the ground becomes saturated, which is what we've kind of been experiencing here recently. And it can be too little, really dry, not enough water in the field capacity or in the fields. A wilting point. The soil has little water that plants can no longer recover from wilting. Roots are no longer taking in water. Wilting is a universal sign of a lack of water available for plants to do processes that they need to do to survive. Excuse me. So what is available water? Well, this is the amount of water between fill capacity and the wilting point. So these are this kind of ideal zone that we want to be in as far as growing plants or plants growing is concerned. The water table is the label or the level beneath the soil, which the soil is saturated with water. Marshes develop where the water table is just below the ground surface. If the water table is not too low, dryness tends to correct itself through capillary movement. Most of the water supply for humans comes from the water table. So, what effect does soil particle size have on its water holding ability? So, the smaller the individual particles are, the more surface area there is. Thus, it will hold more water. Consider a book compared to all of its pages. Okay, so smaller particles are going to be able to hold more water and be able to have more of an adhesive area for water to stick, which is going to lead to more cohesion of other levels of water. Larger particles, not as much adhesion going to go on there. So soil moistures are measured when so soil is going to be weighed when it's dry, and then when the wet is expressed as a percent of dry and wet. And this is something that's done in science a lot. You weigh something that's dry, then you weigh something that's wet. and you subtract the two, and you basically figure out the water weight, so to speak. And soil is no different. All right, so factors that determine the amount of soil moisture, the amount of precipitation, so snow, rain, or even if it's man-made, participation, irrigation. Rate at which soil permits water entry. This is is water going to sit on the top, or is it going to seep on through? Water storage capacity of the soil, evaporation rate, height of the water table, rate in which water can move within the soil, and the amount and type of vegetation. So how can we increase the amount of available water? Precipitation. We can better utilize snow and rain by keeping water on soil surfaces by using windbreaks, keep snow in place, strip cropping, contour strips, or grassland farming. Irrigation may not be practical in some areas. Some areas it may be. Depends on, of course, the financial aspect of it. It's not cheap to do. Secondly, where the water table is. Water entry, so reduce cultivation, green manures, and correct alkaline soils. Storage capacity, evaporation, you can do conservation tillage, shelter belt, strip cropping, and vegetated covering also helps hold water. The last slide, kind of some interesting things here. How much water do plants need? Transpiration ratio, pounds of water to produce a pound of dry matter. It takes over 4,500 gallons of water to produce enough food for one person for 3 meals. So you could look at the number there of gallons per year. It takes 10,000 gallons of water to make 1 bushel of wheat. It takes over 7 inches of rain to make 20 bushels per acre crop. So again, it takes a lot of water for plants to be able to do what they're meant to do. And that plays into everything as far as life is concerned. So if you have questions, let me know. Be sure you complete the lecture form that goes with this. And hope you're having a great week. We hope to see you soon.